let's go ahead and take some derivatives using logarithms, and all of these are going to use other rules. First off, let's do the derivative of y equals ln of 10x. So the notation for the derivative is dy dx, and so I'm going to do dx on ln of 10x. And right away you should be recognizing is that there's an inside and an outside function here. The inside function is g of x equals 10x, and the outside function is f of x equals ln of x. To utilize the chain rule, I need to have the derivatives of both the inside and the outside function. So the derivative of g is simply 10, and the derivative of f is 1 over x, which we just found a little bit earlier. So to complete my chain rule, I'm going to need to take f prime of x and put into that g, and then I'm going to need to multiply it by 10. That leaves me with 1 over 10x, so that's the f prime, and I put the g into it, and then I multiplied it times g prime. Right away you'll notice that a 10 will cancel out here, and that leaves me with 1 over x. So the derivative of ln of 10x is 1 over x. There's another way to do this problem if we first go ahead and utilize our product rule for natural logarithms. Notice that there's a product inside of this natural logarithm, and I can go ahead and break that apart. So when I take the derivative of ln 10x, that's the same as taking the derivative of ln of 10 plus ln of x. Remember, products change into a sum of logarithms. When I take the derivative of ln of 10, well, that's just a constant, so it's going to be 0. When I take the derivative of ln of x, that's going to give me 1 over x. So I'll break it up and take those individual derivatives. And like I said above, derivative of the constant gives me 0. Derivative of ln of x gives me 1 over x. So I get the same answer as when I went ahead and used the chain rule earlier. I just get 1 over x. This one's a little bit more complicated. Now we have y equals ln of 2x squared plus 3x. And in this one, I wouldn't be able to just go ahead and break apart this piece easily. This is one where it's probably best just to do it with a chain rule. So I need to recognize what the inside and the outside function is. So clearly the 2x squared plus 3x is being put into the ln of x. So my g of x function is going to be 2x squared plus 3x, and f of x is going to be ln of x. So my derivatives are g prime of x, and that's going to be 4x plus 3, and the derivative of ln of x is 1 over x. So I need to put the g in place of x in the derivative, and then multiply it by g prime. So below here, you see exactly that. Here is the g put into the derivative of the ln function, and then multiplying by the derivative of the g. Here's another one that's even a little bit more complicated because the inside function now contains a square root. And inside of that square root is x squared minus 1. So to take the derivative of y equals ln of square root of x squared minus 1, in this one I'm going to need two chain rules. So in the first chain rule, I'm going to have my inside function g of x be square root of x squared minus 1, and my outside function f of x is going to be ln of x again. Now, taking the derivative of this g is going to be a little bit complicated. So when I write this out, I'm just going to write out that, oh, I need one more step to do this. But the derivative of the f is no problem. That's just 1 over x. So let's apply this first chain rule. So I'm going to take 1 over x and put into that the g function times the derivative of g, which means I still need to take the derivative of square root of x squared minus 1. To take that derivative, I'm going to start a new chain rule. The inside function g of x is going to be x squared minus 1, and my outside function is going to be square root of x, or x to the 1/2 power. The derivative of the g is simply 2x, and the derivative of the f is going to be 1/2 x to the minus 1/2. What I'm going to need to do is to put the x squared minus 1 into the f prime, and then I'm going to multiply by g prime. All of that's going to go right here. So this is equal to 1 over the square root of x squared minus 1, that was from my first chain rule, times 1/2 x squared minus 1 raised to the negative 1/2 times 2x. This first piece was the f prime, and I put g into it. This piece back here was the g prime. Now notice that there is a negative 1/2 power, so this piece is the same as 1 over square root of x squared minus 1, and I can combine that with the other piece. Essentially what I have is 1 over square root of x squared minus 1 times 1/2 1 over square root of x squared minus 1 times 2x. The 2's are going to go away, and these two square roots can multiply together, giving me just x squared minus 1. So my final answer is going to be x over x squared minus 1. For such a complicated problem, this has a very simple final answer. In the next problem, we're going to take the derivative of x squared times ln of 3x plus 4. You'll notice that there's an inside piece in this ln, so I'm going to need a chain rule, but I've also got a multiplication here. So I'm going to need to use a product rule on this also. The first thing I'm going to do is the product rule, because in taking the derivative of this piece here, I'm going to end up needing to use the chain rule at that point. So we're going to have the u part being the x squared and the v part being the ln of 3x plus 4. So to take my derivative with the u and the v, remember what the rule says. It says v u plus u v, and then we take the derivatives on each of the second factors. So I get ln of 3x plus 4, that's my v, times u prime, so the derivative of x squared is 2x, plus u, x squared, times the derivative of v. Since that's fairly complicated, I'm going to leave the derivative of ln of 3x plus 4 for the next step. In doing that, I'll have to have g of x as 3x plus 4, and my f of x is ln of x. So the derivative of the g is just 3, and the derivative of the f is 1 over x. So I'm going to take my f prime, I'll put g into that, and then multiply by g prime. And that will go in place of this derivative. 1 over x, I put in the inside part, and then I multiplied by the derivative of the inside. So what we have here is ln of 3x plus 4 times 2x plus x squared times 1 over 3x plus 4 times 3. All the derivatives have been taken at this point. We've done both our product rule and our chain rule. But I can simplify this a little bit, and the way I normally do that is this 2x piece. Doesn't matter which order I multiply the ln and the 2x, so I'm going to put the 2x out in front. The x squared and the 3 can come together and multiply this fraction, and that gives me 3x squared over 3x plus 4. That's probably a little bit easier to write down as an answer.